When we're looking at probabilistic forecasting, we need to take a step back first of all and look at why weather forecasting is intrinsically difficult. And this is because of the chaotic nature of the atmosphere. In simple terms, this means that a very small change in the starting state of the atmosphere within a weather model can lead to really large errors developing as you run the forecast forward in time. Traditional deterministic models will simply give one outcome based on that model's starting position, and there's no way really of understanding the confidence within this methodology. Now, probabilistic forecasting uses techniques to vary the initial state of the atmosphere within the model in an attempt to give a spread in outcomes, which ultimately help in us developing confidence around the output. We can then use statistical techniques applied to the range of outcomes in order to convey the likelihood of certain weather situations occurring. And this makes probabilistic forecasts a much more powerful tool than simply relying on single deterministic runs. Looking at a specific example where probabilistic forecasts have assisted our clients, Europe has seen several notable heat waves so far in the summer of 2025. And one example saw temperatures in southeast England exceed 35 degrees Celsius on July the 1st. And on the same day, Paris in France reached around 39 Celsius, so really, really high temperatures. About as early as June 19th, there were indications of a surge of heat for Western and Northwest Europe, but the magnitude of this heat wave or potential heat wave was somewhat less obvious. Around about 1 week out, confidence was increasing for a hot spell, but the chance of a cold front coming in from the west and bringing cooler air in was also in the mix of outcomes. And this uncertainty was clear from our confidence interval products. That means we could see that the upper and lower bounds were still quite far apart and quite far away from the most likely temperature at that stage. Around about 4 days before the event, though, although there was still some uncertainty, that interval range had really narrowed a lot, and this allowed us to give a confident outlook at very high temperatures to our clients across the European sector. DTN communicated this forecast information to our utility providers by using a blend of graphical information showing in the upper and lower bounds, along with expert guidance from our risk communication team to alert those customers to the upcoming heat wave. Our customers were then able to plan certain actions for this to mitigate the risk to their operations. For example, reducing the capacity of their lines in the hottest part of the day, or maybe even shutting down certain power stations which required a lot of cooling to keep them running. By their nature, rare or extreme weather events are not always handled very well by weather models. And if you take that a stage further and just look at one model output, a deterministic approach, you're only limited then to seeing that one possible outcome every time you run the model. And one run may show an extreme weather event, the next one may show no event whatsoever. So you're kind of left a bit blind as to whether it's going to happen or not. Probabilistic forecasting allows the most extreme model solutions to be taken into account and also allows the output to be viewed in the context of all the other solutions as well to see how likely it might be. It also allows us to see how the extreme values being predicted evolve over time. Is there confidence in this, or is it still looking uncertain? There are also techniques to compare the output against climatology, and this can give context to a potential event. Stormy weather in the middle of winter in the northwest of Scotland, for example, isn't that unusual. But stormy weather across the southeastern part of England in the middle of the summer is very unusual. And so comparing against the climate of the area helps to give that context to our clients. Machine learning and AI modelling will also assist in the future in this regard, and there are new models being developed all the time and coming online at an extreme pace. Now, our global forecasting system is agnostic to its inputs, and we're continuously evaluating all the models that are out there on the market, and we include the best of these into our system. And if the next best thing is just around the corner, you can be sure that we at DTN will have it in our forecast system.